Did not record that, no. Thank goodness. All right, here we go. Section 5.8. Let me just take a peek at this. Well, maybe towards the end we're going to learn something a little bit new. All right, but the first part of this, it's really not new. It's kind of review. And like I said, this is kind of one of those lessons that I don't know if it's really even necessary to do, but we're going to do it anyway. So we've talked about this before, and I think I might have even written this down before. Before I even looked at this lesson, okay, I was thinking about this lesson. All right, there's a bunch of ways, several solutions to quadratic equations. And we've kind of worked our way through them in the last, 3, 4 lessons, 5 lessons or something like that. We've actually learned a bunch of different ways to solve quadratic equations. I think the first way we learned how to do it was by factoring. All right, we're going to do a couple examples after I write all these down. So I'm just going to write these down. So that's one way. These are different ways, right, to solve quadratic equations. They didn't include graphing, but graphing is one of them. Okay, sometimes, okay, it's not all the time. Remember we talked about that? Okay, we say sometimes you could graph it. Remember when it crosses the x-axis? Okay, those are my zeros. Those are my roots, my answer, if you want to call it that. All right, but they didn't include that here, thank goodness. But what's another way? We did another thing. I think you had this on the quiz where it says taking the roots. Do you remember that? It says solve by taking the roots. Yeah, I thought it was on the quiz. All right, and then number 3, we all know this one. What is that? Completing the square. Completing the square. And the last thing that we've been doing, quadratic formula. Good. All right, so number 4 is the what? Quadratic formula. Quadratic formula. Only 2 of these you could do every single time. Which one? Yeah, completing the square and the quadratic formula, okay? This, sometimes it works, sometimes it doesn't, depends on the problem. Okay, this, sometimes it works, sometimes it doesn't, okay? You can't always factor something, all right? So that doesn't always work, sometimes it does. Sometimes this is way easier. I think we did one yesterday, didn't we? Where I did it by factoring, then I did it by the quadratic formula, and we compared them. I don't know, didn't I do that? I think I saw that. Remember? You just got to look at it. So I'm glad you asked. So let's take a look. Example 1. So these all say solve. Okay, I'm not going to write that down for every single one of them, but it says solve. Solve for whatever the variable is. All these are x's. So watch this. 3x squared equals 54. All right. So there you go. That's a quadratic, isn't it? Because I could put that 54 on the other side, so this would be 3x squared plus 0x minus 54 equals 0. Wouldn't that be a quadratic? Yeah, remember what a quadratic equation is? ax squared, what? Plus bx plus c equals 0. So you could write it that way. So would you agree that that is a quadratic equation? Yeah, anytime you have an x squared and an x, all right, that's a quadratic equation. But if I wanted to, I could complete the square. I could do the quadratic formula, but it's so much easier to do what? To get x by itself. What would you do? What's just your natural reaction when you see this? What would you want to do to get x by itself? Say it, I can't hear it.
I would do the second one.
But just tell me what to do on this particular problem. Divide by 3, exactly right. Okay, so divide by 3. So when you look at this, you could put it into this form and you could complete the square and solve for x, couldn't you? You could put this into the quadratic formula and then solve for x. But just looking at it, so Mia, this kind of answers your question, you have to look at the problem and then decide which one is probably the best way to do it. I would say between completing the square and quadratic formula, I probably would always opt for the quadratic formula. I don't know of any benefit of completing the square over the quadratic formula. Okay, but that's just me. So divide by 3. That cancels. X squared is equal to, that's 18. Right? So what is this? Have we been factoring at all? No, we haven't been factoring. So really, what are we doing? Taking the what? The roots. So right now we're actually going to take the root, okay? Take the what root? The square root, okay? So again, you could put a square root right there, but do you have to do that? No, you know it's going to go away, don't you? You know that's going to go away when I take the square root. What do I have to do over here, though? I got to take the square root, put a plus or minus. So what do we get? X equals plus or minus square root of 18. But I don't want to leave it like that, okay? What do I want to do? I want to take square root of 18 and break it down. What am I going to break this down to? Okay, but you went a step ahead. Let's go step by step. 9 times 2. Agreed? Now, you could probably skip a little step. Like normally, if I was teaching this for the very first time, what do you think I would write down? Square root of 9, square root of 2. Would you agree? But I think you could go from here to here in your head, don't you? Right? You did it already. You went from here and did it in your head and got it. And that's fine. I don't have a problem with that. But I'm just trying to teach you how to look at it. So what's the square root of 9? It's 3. You can't do anything with square root of 2. So the square root of 18 is the same. You got to put the plus or minus. It's what? 3 square root of 2. So that is what your x is. So that's one way, right? One way to solve that quadratic equation. Okay? It's just a matter of looking at it and trying to figure out what is the best method to use. Let's do another one. What if I gave you this? This is part B. It's still example 1, but it's part B. What if I gave you 4x squared minus 12x equals 0? Is this a quadratic? Sure. Okay. Your A is 4, your B is negative 12, your C is 0. Again, if you wanted to, you could complete the square and solve for this. All right. You could put it into quadratic and solve for it. But what do you think the best method to do here? I would factor it. That's correct. So what's in common? Now, if you wanted to, you could divide everything by 4, couldn't you? All right. I didn't do that. It should still work. But I would say factoring. So what's in common with both of these? Greatest common factor. There's a 4, right? Because 4 is the biggest, the greatest common factor. There is a 2 in common, but 4 is the biggest one. And then what else? I got an x squared and an x, 4x. So that's in common, so I'm going to factor it out. Okay? And then what do I have left? If I take this and divide it by 4x, I get x. Take this and divide it by 4x. 12 divided by 4 is 3. X divided by x is 1. Let's close the parentheses. That equals 0. Remember what we do? When you got two things multiplied together and your answer is 0, what do? We could set them both equal to 0, right? So 4x, set that equal to 0, and set that equal to 0. Divide by 4, so what's x equal to here? 0. What's x equal to here? 3, and that's your answer. Okay, 2 answers because you got a quadratic. We good? All right, so that's the easiest way to do it. If I wanted to, I got a lot to do in this lesson, so I'm not going to do it. But if I wanted to, I could complete the square, right? I could put a plus blank, take half of that, 6, square it, 36, 36, get a perfect square, blah, 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 blah. I could do that, couldn't I? All right, and I'd still get the same answer. I could put it into the quadratic formula. Negative b, so that'd be 12 plus or minus square root of b squared. That'd be 144 minus 4 times a times c, right? And so forth. Everybody got that? All right, you could do it that way and still get the same answer. This right here is probably the best way to do it. All right, let's do another one. I think I can squeeze it in right here. So let's solve for this. 3x squared minus 4x plus 5 equals 0. All right, here we go. We got to solve for x here. Just looking at it, what do you think? I would definitely use the quadratic formula on this. All right, this is a little, you can't really factor. There's nothing you can factor with all three of these. You can't divide anything by the same factor. There's really no other choice, I think. This may factor. It probably doesn't. All right, yeah, because of 5. So I wouldn't even mess with that. I would go right to the quadratic formula and then I would use that. I'm not even going to write the quadratic formula down because you got it memorized now, don't you? So x equals negative b. What's negative b? Well, no. The numbers. I said I'm not going to write down the formula. So it's negative b, which is a positive 4, plus or minus square root b squared, which is, do that in your head. What's this squared? It's 16, all right? Minus 4 times a, which is 3, times c, which is 5, okay? We'll do that in a second. Over what? 2a, 2 times 3. All right, plugging everything in is not that hard. Simplifying it sometimes can be a bit of a challenge, so let's do it. 4 plus or minus. See, Hunter, you said you wanted to do more of these. Here we go. 16 minus, what's that? 12 times 5 is 60. And then over 6. Keep on simplifying. 4 plus or minus square root. 16 minus 60, what's that? 44, is that right? Negative? Negative inside the square root. What does that tell you? Going to have an I. That's right. Okay. Since you know you're going to have an I, let's split them up. Okay, that's kind of how they want it. They want it as a complex number, so let's do it like this. Let's go 4 over 6 plus or minus. I don't know. Can you do this in your head? If you can't, let's do it right here. Square root of 44 is what? 4 times 11. All right. Square root of 4 is 2. Square root of 11. Don't forget the what? The I. Or you could put the I out in front right here, or you could put it in between the 2 and the square root if you wanted to. I don't know. I always like to put it on the end. I think they put it, I don't know where they put it. Did they put it before it or in between? Can't remember.
Well, in the first one, they put it after the 2, and then the second one, they put it after the 11.
Yeah, so it all just depends. Just make sure, remember we talked about this yesterday, just make sure that I doesn't look like it's underneath that square root. Put it far enough away from it so you know it's not part of that square root. Do we leave our answer like this? No. We can simplify. What's this going to be? 2/3 plus or minus. What happens here? Once, 3, square root of what? 11 over 3, and then I. All right, so I do think that that's the best way to write it, especially if you have an I. If you didn't have the I, it would be perfectly fine just going 2 plus or minus squared 11 all over 3. All right, that'd be okay. But since it has an I, this is the real part, this is the imaginary part. That's why they split it up.
So on a test like that, because you're going to ask us, like, give us a problem and have us solve it each time.
No, I'm not going to have you do it a bunch of ways. I'm just going to have you solve it, whatever way you want to solve it, okay? But it kind of flies in the face of this example right here. I don't know. On the homeworks, it may possibly say, do it a certain way, right? Solve this by completing the square, or solve this by quadratic formula, or solve this by, I don't know, what does it say?
It says I identify the simplest method.
Okay, so basically they're just saying do it whatever you think is the best way to do it. Is that correct? Is that basically what it's saying? Okay, because I don't have it in front of me right now. All right, but this kind of flies in the face of what I just said. So this is example 2. They're going to give you one problem, but they want you to solve it 3 different ways. Same problem. All right, so let's do it. So we're going to do it, first of all, by factoring. Yes.
I know it's like next month, but like, are you gonna go to any kind of PSATs and
Am I going to do stuff for PSAT?
Yeah, there's math on PSATs.
Am I going to like review for it? I'm not. Is that what you're asking?
Like, is there like, are you gonna like hand us anything like?
No. No, that would be another course. It'd be good if we did have a course, PSAT or SAT prep or something like that. But you go online, there's a million. I heard that Khan Academy has a good SAT prep on there. Are you listening to me? I'm answering your question. So no, we're not doing anything specific to the SAT in here. All right. To tell you the truth, the stuff that we're doing now, I kind of doubt. I think I think the hardest stuff they have as far as math is the geometry. All right. They don't go into really high level math on the SAT. Most of it's thinking kind of stuff. I don't know. Quadratic. It's not all word problems, no. All right. Completing the square quadratic formula. Everybody got that? All right. So we want to find, this is factoring. All right. We want to solve the same exact problem, but we want to do it 3 different ways. So let's do it the first way. So 4x squared minus 28x plus 49 equals 0. Now, at first glance, this looks like I would go right for the quadratic formula, doesn't it? Okay, and you could. We're going to do it in a few minutes, all right? But there is a better way to do it, I think, and that's by factoring. You're like, well, I can't factor that. Well, yes, you can, because look at it. It's a special type of factoring. How do I know that it's a special type of factoring? What am I looking at? It's a perfect square, right? Because I'm looking at this. Is that a, can you square something to get 4x squared? Yeah. What about the last one? Yeah. When I see that, that triggers something saying that this is a perfect square, all right? And it is. Let's just see if it is. If I take the square root of this, it's what? 2x. If I take the square root of that, it's what? 7. How do I know if it's a perfect square? If I take this and I do what to it? I double it, it should be the middle coefficient. Is it the middle one? It is. So that tells me that this is a perfect square. We've talked about that before. All right, so that means it's going to look like this. Do you agree? All right, so what do we put here? 2x. What's my sign always going to be? This one right here. Okay, and then what do I do here? Take the square root of that, 7. And now it's kind of easy to solve. Now I can do it by that, what do we call that? Taking the roots method. All right, everybody see what I did right here? Just factored it. Now, not every quadratic can you do that to, but on this particular one you can, so you might as well do it. You just have to look at it and think about it, okay? What do we do? Square root both sides. If I square root this side and I square root this side, what do I get? It's just a 0, isn't it? So this actually works out pretty easy. We can do the rest in our head. Add a 7, then what? Divide by 2, so x is 7 over 2. So this is one where you actually just get one answer. Okay, even though it's a quadratic, you just get one answer. So that's kind of interesting. That was pretty easy, right? All right, let's do it another way. So that was part A. I don't know if I can fit all 3 here. Let's do it by completing the square. So let's rewrite it. 4x squared minus 28x plus 49 equals 0. So if I'm going to complete the square, what am I going to do first? Well, I think it might be easier to just do what first? Remember, to complete the square, you want this to be a 1, right? So we're going to divide everything by 4. You could have put this on the other side first. That would have been fine. Either way, it doesn't matter. You do it here or you do it in the next step. Doesn't matter. So what happens here? X squared minus what? 7x plus what? Blank. Let's move this to the other side now. What am I going to get now? Negative 49 over 4. Everybody with me? Yep. And then let's figure out what's going to go here. How do I know what's going to go here to make this into a perfect square? Take half of this, 7 over 2, and do what to it? Square it. So that gives you 49 over 4. So this is 49 over 4. But check this out. This also, you got to add it to the other side as well. What happens to the other side? It goes to 0. So check this out. I got this, right? And x minus, what's the square root of that? 7 over 2 equals what? 0. Square root both sides, just gets rid of that. Add a 7 over 2. Check it out. I get the same exact answer, don't I? Which way would you prefer to do it between the two? The left one, right? This one definitely right here, okay? If you understand, but you got to see it. You got to realize that this and this, I guess, makes it into a perfect square. if you look at that, if you remember that, then sure, that's the easiest way to do it. You just gotta realize it. But this still works, doesn't it? Remember, completing the square will always work. Will always work with a quadratic. What's another thing that will always work? The third one, right, which is what? Quadratic formula. So let's do that one. So this is part C. So this is 3x squared. Doing the same exact, nope, it's the wrong one. It's looking at the wrong one. It's 4x squared. Minus 28x plus 49 equals 0. So you could have gone directly to this and used the quadratic formula. So let's do the quadratic formula. Negative b, so that gives you 28. Put x equals 28 plus or minus square root. Now this is a little ugly, 28 squared. I would put it into a calculator, 784. There's my b squared minus 4 times a, which is also 4, times c, which is 49. Already it's getting a little ugly, isn't it? That's a terrible line. Let's try this again. Not much better. Over what? 2a? 2 times 4. All right, let's simplify this. 28 plus or minus square root. Now, watch this. This thing right here, if I put it into a calculator, I'm going to get 784. All right, so what's 784 minus 784? 0 square root is what? Okay, yes. And that's over 8. All right, so what do I get? I get 28 over 8. What would you do here? Yeah, what goes into both? 4 goes into both, right? 4 goes into that 7. 4 goes into this twice. Does that look familiar? There you go. This was kind of ugly because you had to go to a calculator, didn't you? You probably didn't do that in your head. I didn't do it in my head. I had to go to the calculator. So absolutely, factoring in this particular situation was definitely the best way to do it. Hunter, what's your question?
So if you were to take like a problem like 49c squared plus 28c.
49c squared.
Like I'm just like giving an example here, like a perfect square. If you had like 49c squared
49c squared
plus 28c
plus 28c
plus 4,
plus 4.
isn't that a perfect square?
I don't know, is it?
So yeah,
Yeah. So
how
take
would you like factor that?
it would just be this 7c plus 2. Right? Again, you always look to that sign right there because this one's always going to be positive no matter what, right? Well, nah, I shouldn't say that. Not to begin with. If it's a perfect square, let's say it that way. If it's a perfect square, then that will always be positive. Okay, this could be positive or negative, but that one's always going to be positive if this is a perfect square. Make sense? Okay. All right. We good with that? Less than 10 minutes. Wow. All right, well, let's see what we can do. Let's write some stuff down. Here's a word that you probably haven't heard before, at least in this setting. Discriminant. All right, it's pretty easy. You remember the quadratic formula, right? Negative b plus or minus what? Square root of, what was inside the square root? B squared what? Minus 4ac. That right there is considered to be the discriminant. Don't recall. I might have. I just can't remember. I'd have to think about it. Anyway, that's called the discriminant. Everybody see that? All right, so it's the stuff under the square root in the quadratic formula. So what we can do is we can just look at the discriminant and give us an idea of what kind of answers are we going to get when we actually solve for x. You hear what I just said? Okay? A couple of you are nodding out. Some are beyond nodding. So watch. We'll use the letter D for discriminant. Makes sense, doesn't it? All right, so if the discriminant is greater than 0. So what kind of numbers are greater than 0? Positive. That's what I was looking for. A positive number. Any number that's greater than 0 is a positive number. All right. you're going to get, I'll put a little arrow, I'll put a double arrow. I don't know why I put a double, but I did. A double arrow, you're going to get 2 rational solutions. So if you just look at the discriminant, right, and you put the numbers in, right, work it out, if that comes out to be positive, you know your answer, you're going to get 2 rational solutions. What does that mean by rational? Rational number. What's a rational number is what I'm asking. Like what? 3 over 2 is a rational number, okay? 3 over 2. I'm just giving you examples. So you might have 3 over 2 and maybe like just 1. 1's still considered rational, right? Right? 4 over 4 is 1. 2 over 2 is 1. 1 over 1 is 1. So they're rational numbers. So that's one possibility. You got another possibility if the domain is positive or greater than 0. You could get 2. We're going to do the negative in a second. Let's do this. I should have done this. Not a perfect square, okay? Because these, you could have a perfect square to get some answers here. But if it's not a perfect square, then what you're going to do is you are going to get 2 irrational solutions. What's irrational? What's an irrational number? Well, a rational number, you can always make it into a fraction, all right? And so your decimal is always going to either stop or it's going to repeat, all right? Like 1/3. It keeps going, but it just repeats the same number, right? You with me on that? So an irrational number is anything basically with a square root, all right? And that doesn't come out even. So for instance, this is just an example. 1 plus or minus square root of 13 over 4. We've seen answers like that, right? So you got 2 possibilities. So when your discriminant is positive, you might get answers that look like this, and you might get answers that look like this. All right? Do you see any i's anywhere here? No, because when are you going to get an I? When the discriminant is what? Is less than 0. So if the discriminant is less than 0, you are going to get 2 complex, they say conjugates. I'll show you what I mean. We've talked about that word conjugate, right? So here's an example, like 1/4 plus or minus. Now it's complex, so it's got to have a what in it? It's got to have an I in it, okay? Which makes it a complex number, okay? So when your discriminant is less than 0, when you look at this, you're like, oh, it's less than 0. That means it's negative. You know that negative. Remember, we always do that. We look at it, we say, oh, there's a negative, so what are you going to do with it? You're going to pull it out and make it an I, right? And that's basically all this is saying. And you could have your discriminant. What's your other possibility? Your discriminant could be positive, it could be negative, or your discriminant could be what? Equal to 0. All right, so if your discriminant is equal to 0, then you get 1 rational solution. And we did one already. Remember that 7/2? Okay, that was 1 rational solution. Why? Because the discriminant came out to be 0, didn't it? Right there. There it is, right there. You got it? And look, you got a rational number. Okay, it's not a square root or anything like that because your square root's taken care of. It's over with, right? So there you go. So what they're going to ask you to do is they're going to give you some stuff. When do I get out of here? 14? Okay, I got like 2 minutes. So, so what they're going to do, keep those notes right there. They're going to give you a quadratic. They're not going to necessarily ask you to solve for it, to solve for x. They're just going to give you a quadratic, and they're going to ask you to determine the number and nature of the solutions. All right? So if you had this, you don't have to put it all into the whole entire quadratic formula. What do you have to put it into? Just under the square root. So what is it? B squared, which is, we'll just do this. 5 squared minus what? 4a and then c. And let's just see what what happens. That's 25. That's 12 times 8, which is what? 100 it's 96, right? 96. So look, I don't even care what the number is. What type of number am I going to get here? And it is negative 71, but it's negative, right? So what happens when my discriminant is less than 0? I'm going to get what? 2 complex conjugates. They don't even ask for the answers. They just want you to say what? 2 complex conjugates. Everybody with me on that? And that should make sense just because of the nature of a square root, right? If a square root is negative, you know you're going to get an imaginary number. If the square root is positive, you know you're going to get a real number. Okay, sometimes you'll get, if it's a perfect square, sometimes you'll get rational answers. Sometimes you'll get irrational answers. And if it's 0, you're just going to get one answer. All right? There's one more thing we didn't quite get to, and I really wanted to, but you should be able to do most of the stuff here. All right? So it's section 5.8, page 220. This is all on facts, so you could always look it up. 13 to 35, and you just do the odds. Now, there's probably some at the end where it says write the standard form. Okay? You hear that? When it says write the standard form of a quadratic equation, don't do those because I haven't talked about it yet. We'll talk about it first thing tomorrow. Okay? And I don't know what number. I don't have the book in front of me, so I don't remember what numbers they start with. But again, you're just doing the odds. You're not doing all of them, just the odds.